Hello, everyone. My name is Dale Seed, and I'm from InterDigital. I believe I've met or spoken with many of you in recent talks and discussions focusing on various 1M topics, and I wanted to say thank you once again for the opportunity to speak with you today. For today's talk, I'd like to give you some more information about the One Transport Data Marketplace solution. First, some high-level overview, along with a bit of history about One Transport. One Transport is a 1M based smart city service. It's commercially deployed in the UK with plans for future expansion as well. The One Transport solution offers a data marketplace for the sale and exchange of transportation-centric data, and the service enables data owners to publish their historical data as well as their real-time data such that it can be discovered and accessed by other data enhancers and consumers. Cordant is the company that commercially deploys One Transport along with several of its partners. And Cordant is a separate and dedicated smart city-centric company that was spun off from InterDigital. Before its commercialization, if we look back a little bit at the history, One Transport started off as a UK government-funded smart city project, and that was made up of several partner organizations, including InterDigital as well as others. The project was very successful, and it resulted in a pre-commercialized solution. When the project concluded in 2017, Cordant began the commercial deployment of the One Transport solution. As part of the deployment, Cordant commercially hardened and scaled out the solution and added several commercial-centric features. For example, it added a framework for data owners to offer licensing terms for their data, as well as the ability to charge and bill others for accessing and using their data. Presently, the commercial deployment services about 300 data providers, having both real-time and historical data feeds feeding into as well as out of the One Transport service, as well as many different types of data consumers that are accessing the data and making use of the data to build exciting applications with it. So leveraging the One Transport data marketplace enables many types of transportation-centric services, such as those related to traffic congestion management, parking, connected autonomous vehicles, just to name a few. If we take a little bit closer look at the One Transport solution, the commercially deployed service is, again, it's deployed by Cordant, and it's powered by the Cordant IoT platform, which is based off of the 1M standard. The service uses the underlying Cordant platform, which is hosted in Microsoft Azure Cloud to achieve commercial scaling and reliability and availability. The platform can be accessed by various types of stakeholders, such as transportation authorities, application developers, car OEMs, insurance companies, just to name a few. These stakeholders create products and services that help enable new and exciting product offerings, such as improving travel experiences for many different commuters. One Transport, just to be clear, it's not an application or it's just a service. Rather, it's the goal of One Transport was more to form an ecosystem consisting of data providers, enhancers, and consumers, and breaking down the barriers to entry and opening up the marketplace for these different stakeholders to provide their services, using a freemium model where it would be free of charge, or at a premium type of model where they could charge and create revenue streams from this. So if we take a look at the different stakeholders, at a high level, there are data providers that import their data into the One Transport service, as well as data enhancers, which access the data from data providers, then enhance that data and publish the data back into the service to provide higher level, more valuable data. A good example of this would be like an analytics service provider. Likewise, there's data consumers who simply use one transport just to access data and retrieve and pull data out of the service and use that data to enable the ability for them to use the data within their applications. So through this ecosystem of data providers, data enhancers, and data consumers, it creates a cyclical type of environment where these data feeds that are created, that they build upon themselves, starting with lower level data that gets enhanced and building higher level data, which in turn creates more valuable data, and the process continues and repeats. Using this ecosystem, innovation then thrives through a community of data providers, enhancers, and consumers. And it creates, as I mentioned before, a simpler go-to-market path and an opportunity for revenue generation. So if we take a closer look at what technology is enabling the One Transport service, here on this slide we see that we have the Cordon IoT platform, which again is a 1M2M standards-based platform. It's supporting the core capabilities of the 1M2M standard, especially those focusing in on the data management plane to allow the data brokerage aspects of the One Transport service. But it also offers, additional services such as security, as well as eventing for subscriptions and notification functionality, as well as some of the statistic collection and charging, and discovery, and various others. Layered along with the Cordon IoT data platform is a web services portal that is the forward-facing portal for the service. And this basically exposes the Cordon IoT APIs to the subscribers and of the service, and provides functionality such as the licensing and the pricing, the subscription and the enrollment of the users, and the front ends for the usage and the metrics and the billing. So together, the web portal along with the Cordon IoT platform make up the One Transport service. Some types of applications that are enabled by One Transport include things such as enhanced wayfinding, including routes and parking, accident prevention and awareness, enablement for autonomous vehicles, congestion and pollution reduction, transit sharing, and optimized road maintenance and safety management. So on the next few slides, let's take a little bit of a closer look at a couple of these examples. Here on this slide, I'm showing a use case involving One Transport being used to manage high traffic volumes. For example, a smart city command and control center can observe congestion data from live traffic streams, process this data using predictive analytics, and then make adjustments to traffic control signals, suggested route signs that are displayed on roadsides, as well as public transportation schedules. All of this, again, can be enabled with the One Transport service and its Cordon 1M2M based IoT platform, providing the data that helps fuel the applications and use cases such as this one. Here on this next slide, I'm showing another use case, this one involving a method for understanding and providing recommendations for different modes of transportation within a city based on variables such as the traffic congestion, the mass transit schedules and delays, for example, buses and trains, maybe some alternative transportation availability such as the rental bikes or motorized scooters in the city, as well as some additional complementary information like the weather, as well as the air quality and the availability of bike paths and things like that in different regions of the city. All of this information, again, being very useful for commuters who are looking to plan their journeys and making day-to-day and route-by-route decisions on what options they have and what forms of mobility that they can use to perform their commute. And again, all this diverse information can be pulled together through the One Transport service and be made readily available and used by various stakeholders and, that take part. Here on this slide, I'm showing a use case for a little bit more of a recent type of scenario and use case that's making use of the One Transport service. And this is one involving connected autonomous vehicles. And the point I'm trying to get across on this slide is in order for the connected autonomous vehicle to reach its mass deployment and really come to fruition, there's a lot of different stakeholders that can play a role in that. For example, we have road authorities, intelligent transportation system operators, insurance companies, smart city managers, emergency services, vehicle manufacturers, and OEMs. All of these are stakeholders that really would like to either access information, provide information, or enhance information flowing to and from connected autonomous vehicles or the devices that interact with those vehicles, such as roadside units and sensors. So this is another use case that's currently where One Transport is being used to pull together this information and allow these stakeholders to share it and use it with one another. What I'd like to do next is just show you a brief demo of a One Transport enabled application. This application consists of a dashboard that was built as part of a smart city command and control center, leveraging the One Transport service. So here on this dashboard, I'm showing you a map of the greater London area. And displayed on this map are various sensors, including vehicle counters, journey time predicting sensors, mass transit monitors, air quality, as well as weather sensors. So a large diverse set of weather sensors, a large diverse set of various types of sensors. And what we see here, each bubble on this dashboard represents a set of sensors that's deployed throughout the London region. And if you hover, as I hover over each one of these bubbles, you can see that the sensors are deployed in the region that's outlined by that respective area. Now, if we start zooming in on different regions of the city and different areas that have these sensors, I can start to show you some different types of functionality that's enabled by the data that's provided by these sensors. For example, in this first case, I'd like to show you some road closure type of example where we have different regions of roads that can be closed and information that can be shared and reported about the road closure. For example, here we have a gas leak that occurred in a certain part of the city, and we have a boundary and a perimeter that's been established, and those roads have been closed due to that gas leak. Also shown on this part of the dashboard is we have different bus routes being displayed with the different bus lines through the city and information about those bus lines. If we zoom in on a different area of the city, we have, in this case, we've got some information just being displayed about different traffic congestion information. So we've got red, green, and orange being displayed and used for the different road segments. So if we hover over a green road segment, we can get some information about the fact that the travel time on this particular road is averaging about 3 minutes, which is the typical travel time for this road segment. Whereas if we go to a different road segment, let's say an orange one, we can then get some information that basically says that the travel time on this one is running a bit over the normal. So here it sits 6 minutes instead of 5 minutes. The additional types of information here, I'm also showing some train information. We can display train information for a different railways throughout the city, as well as if there's any alerts or notifications regarding this railway. This one is currently suspended and it will resume at a later time and scheduled for the morning time. Other things we can display is the vehicle counter information. Here we have vehicle counter sensors deployed through the roads that count vehicle counts, either real time, like I'm showing here, that currently we have about 30 vehicles per minute going through this road segment. And also stored in the One Transport service is also historical vehicle counter information. For example, this chart right here is giving you a year-to-year summary of average vehicle counts through this particular roadway. This type of information can be used by application developers to not just access real-time information, but also historical information, which could, again, enable different types of use cases. Zooming into a different region of the city, just to show you, there's some air quality sensors being deployed here. So these air quality sensors can measure things like particulate matter, and then also whether that's low, high type of reading compared to what is expected and normal, nitrogen dioxide, as well as ozone. Also have some weather sensors in the city, and that information can be also displayed as well. So all of this information, again, is fueled and coming out of the One Transport service, and all of it is based off of a data schema and model that is standardized by the 1M2M standard. And it's coming from devices that are either native 1M2M devices, or in many cases, these devices are not 1M2M devices. They are traffic sensors that may have been deployed many years ago, and that deploy and measure sensor readings in various types of formats. However, when the information is inputted into the system, it can be interworked and adapted such that it can be displayed and stored in a 1M2M schema-based model, which then that allows the application developers to just use one consistent model, making their life a lot easier and consistent for them. Along those lines, let me just show you a little bit deeper. I will go kind of into the One Transport service and take a look at the data brokerage and data sets that some examples of those that are being stored. On this, I'm looking at the One Transport website right now, and these are some example data sets that have been published by various data providers into the system. And each one of these has a subscription with the service, and they upload and publish their data into the One Transport service. If we go a little bit deeper and we take a look at an example, here I'm looking at a car park in the city of Birmingham, UK. And if we click on the car park, we see that car park is modeled as a 1M2M application. And it's using the 1M2M data model, and specifically the 1M2M application resource, the AE resource, which is shown here on the right. And this car park is uploading information about the status of the car park. And when it does that, it's uploading it into some data management type resources defined by the 1M2M standard. Here we're showing a container resource for the car park. And within that container resource, there's car park information being uploaded on a periodic basis and being time-stamped. So here we're showing things like the occupancy of the car park, as well as the percentage full of the car park, along with additional information. So this can be used to access real-time information as well as historical information that's stored in the One Transport service. So as you can see from this, The one transport service is indeed using the one M2M standard to store its data in the data model and schema defined by the standard. In addition, the service also offers the ability for different pricing models as well as different subscription models into the service based off the type of user and what they're looking to do with their data, as well as different licensing models. If somebody would like to upload their data, depending on how they would like to license their data, the One Transport service offers different licensing models. For example, the open government license would be one option for them to use to make their data available and have it licensed in a certain manner such that it could be shared. So at this time, I think I'd like to wrap it up. My time is up, and again, hopefully you were able to gain a better appreciation of the One Transport offering, as well as how it makes use of the one M2M standard. It was my pleasure to provide you with this information, and again, I'd like to say thank you for the opportunity to speak with you today. Hopefully, we can have some questions. If anyone has any questions, I'd be happy to try to answer them. Thank you very much.